In this next batch, we're going to graph the rational functions that have more than one factor in the denominator. We're going to deal with a very basic type of rational function where the numerator will always be positive or -1. How we're going to graph these is on using a number line. We're going to make a sign chart. And first, we're going to have to identify where the vertical asymptotes are. And again, those are going to happen from the denominator. Now, we look at each factor and ask ourselves what's going to make this factor equal to 0. And since -4 will make this factor equal to 0, our first vertical asymptote will happen at x equals -4. The next one is going to happen when x minus 5 is equal to 0, and that's when x is equal to +5. Now we'll go ahead and identify those on our number line just by placing a -4 and a +5 in the correct order. Then we draw our vertical asymptotes off of those. Next, we don't have to actually find any points, but we will have to test each of these three intervals. So the first thing I'm going to do is pick any number out here. It's got to be negative and it's got to be less than 4. So I'm going to take like -1 billion. That way, all I really care about is the sign. I really don't care about what the actual number is. But I'm going to go back into this original function up here and substitute -1 billion. And if x equals -1 billion, -1 billion plus 4 is going to be a negative number. And -1 billion minus 5, that will be a negative number. The 1 in my numerator, that will always be a positive number. So I'm looking at a fraction that has a positive numerator, and the denominator is going to be a negative number times a negative number. Well, that would be positive divided by positive. So overall, that fraction is going to be a positive number. Now, as we pass over -4 and we pick a number inside of here, in between -4 and 5, we pick the easy one, 0. And 0 plus 4 is now 4, a positive number. 0 minus 5, still negative. And 1, still negative. So looking at these three signs, we'll have a positive divided by a negative number, making every number inside of this interval negative. Finally, we'll pick something out here, something very positive, like +1 billion, and we'll plug that into our fraction as well. So +1 billion plus 4 is positive, +1 billion minus 5 is positive, and 1 always positive. Now when we look at this fraction, everything is positive, so the whole fraction will be positive. Knowing the sign of every value along our graph is going to be very helpful for us, because now we can come up with the shape of our graph. It's got to approach our horizontal asymptote, which will be the black line, the x-axis, and it has to approach both of our vertical asymptotes. So on this first interval, when everything is positive, that means my graph has to be above the x-axis. So it has to get close to this vertical asymptote and to the x-axis. On the middle interval, it's going to be negative, and it has to approach all three of our asymptotes. It has to get kind of close to our x-axis, it's got to get close to this x equals -4, and it's got to get close to x equals +5. Finally, on the last interval, our graph has to stay above the x-axis and get close to both of our asymptotes. So getting close to the vertical asymptote at x equals 5, and our horizontal one at y equals 0. So let's do this a couple more times. If y equals 1 over x times x plus 1 times x plus 4, we'll have 3 vertical asymptotes, and they will all come from the 3 factors of our denominator. For x, the vertical asymptote will be x equals 0. For x plus 1, it'll be -1. That'll make that factor equal to 0. And for x plus 4, x will equal -4. We'll make that factor equal to 0. Now we label all 4 of these numbers on our number line, putting them in the proper order. So first will come -4, then -1, and finally 0. And draw in our vertical asymptotes at each of these spots. Next, we're going to test each interval to determine whether the entire fraction will be positive or negative. So pick something very negative, like negative a billion, and plug it in. Well, negative a billion is negative. Negative a billion plus 1 is negative. Negative a billion plus 4 is negative. And 1 is always positive. Since we have an odd number of negative signs in this fraction, the entire fraction will be negative. Now, as we pass over negative 4, we're going to pick something in here like negative 3. And we'll see that negative 3 is negative. Negative 3 plus 1 is negative. Negative 3 plus 4 changes to positive. So as we passed over negative 4, it was the factor x plus 4 that changed from negative to positive. The numerator is still always positive. And now when we look at the entire fraction, there's an even number of negative signs, which will cancel each other out, making the entire fraction positive. Now pass over negative 1. That's going to change the sign of x plus 1 from negative to positive. The entire fraction now will be negative. Finally, pass over 0, making x go from negative to positive. Now everything is positive, so the whole fraction is positive. Once we've identified whether our graph is going to be positive or negative, we can sketch it in as being above or below the x-axis. On the first interval, our fraction is going to be negative, so we'll get closer to both of our asymptotes below the x-axis. On the next interval, we'll stay above the x-axis, but get closer to our horizontal asymptote and our vertical asymptote at negative 1, as well as the vertical asymptote at negative 4. On the third interval, again, we'll get close to our asymptotes, but now stay negative, so close to the x-axis, the vertical asymptote at x equals negative 1, and the vertical asymptote at x equals 0. Finally, on the last interval, we'll stay positive, so we'll stay above the x-axis, getting close to the vertical asymptote of x equals 0 and the horizontal asymptote at the x-axis. And there's a good sketch of our graph. Let's do one more. For this one, we'll have negative 1 in the numerator instead of a positive 1, but x minus 3 and x minus 10 in the denominator. Again, first identify the vertical asymptotes. Since the first factor is x minus 3, the first vertical asymptote will be at x equals positive 3. And the second factor is x minus 10, so the second vertical asymptote will x equal positive 10. Identify both of those numbers on our x-axis and graph the vertical asymptotes. Next, test a number on the interval. So I'll pick negative a billion and plug it in. Negative a billion minus 3 is negative. Negative a billion minus 10 is negative. And now our numerator is negative 1, so that's going to always be negative as well. Looking at the fraction, we have 3 negative signs, making the entire fraction negative. Now what will happen is on the test, every one of these rational functions are all going to work the same, where once we have this first sign, we are going to know that the next one's going to be positive and the last one will be negative. If you're unsure, test a point on each interval. So pick a number like 5. 5 minus 3 is positive, 5 minus 10 is negative, and negative 1 is negative, making the entire fraction positive. Then pick something very positive like a billion. A billion minus 3 is positive, a billion minus 10 is positive, but negative 1 is still negative. Then the whole fraction is negative. Finally, we can sketch the graph. On the first interval, our graph is going to be negative, so sketch it below the x-axis, getting close to both the vertical and horizontal asymptotes. On the middle section, we'll be above the x-axis, so get close to the x-axis as well as both vertical asymptotes. And finally, on the last section, we get close to the vertical asymptote and the horizontal asymptote, but we'll stay below the x-axis. And that's how you graph the rational functions.